So, welcome to this training module 1 of the ReUseHeat project. And this training module will be based mostly on what we have in work package 1, but we will focus on the role of urban waste heat recovery in energy systems. So it's from a much kind of broader perspective, kind of as an introduction to using these urban waste heat sources. And my name is Steffen Nielsen, and I'm an associate professor at Aalborg University in Denmark. And I have worked for 10 years with district heating systems and energy planning and mapping of energy sources and these things. And the content of the module will be these 4 points. First, I will talk a bit about what we call smart energy systems and fourth generation district heating. Then I will go into the role of waste heat recovery in district heating. Then we have a part about mapping of these waste heat recovery potentials. And then we have the fourth part, which is energy system analysis of waste heat recovery on national and urban scale. So this is more where we look into how can it actually be used in the energy systems. And if we start with the first part, the smart energy systems and fourth generation district heating.
Smart energy systems is very important if you wish to identify the most affordable and best solutions for the green transitions in the future. It is when you take the smart energy systems approach and combine the different sectors and take this cross-sectoral approach that you can find the best and the most affordable ways of using the storage in your system.
Then that comes from a very general approach that we have developed here at Aalborg University, and it has been kind of used everywhere nowadays. But it comes from around 10 years ago. Then we could see that a lot of energy planning was done within the different sectors. So we heard a lot about smart grids and so on, but they were only focusing on electricity systems. But we found out to find the optimal kind of solutions for when we look into the future and we want to reach these, you could say, the carbon neutral energy systems in 2050 and so on. Then we need to look into these smart energy systems where we try to integrate both the electricity system, the thermal systems, district heating and so on, but also gas grids. So if we have a combination of all of these systems, then we can find kind of more optimal solutions because we can use the different systems, for instance, for storing the energy and find synergies within them. And if we look at the schematic here, you can see out here we have our resources, and in the future system that will be renewable energy sources. But then you can see that we can convert the electricity, for instance, to fuels that we can store for instance, as gas, and that's much more efficient than storing it in electric storage. We also have electricity storage, for instance, there are a lot in Norway and so on that's useful. Then another one, and that's also an important part of this project, is that you can use heat pumps or store the electricity as heat in district heating systems and thermal storages and so on. And then you find a lot of synergies for these and find a more efficient solution if you try to look into all of these options. And we made a video of it. If you want to know more about these smart energy systems, then you can go to YouTube and watch this video. But you could say a big part of this is kind of a schematic of smart energy systems. Then we have used it or applied it in different contexts. And I'm sorry for this being in Danish. But here you can see in Aalborg, the city I'm from in Denmark, then we have actually used the smart energy systems approach, and you can see out here the different energy sources, and this is also 100% renewable energy, and we have to the right all the demands where we both have transport, but also heating down here and industries and electricity. And what's interesting in the context of ReUseHeat is that you can see we have district heating is a very large part of these smart energy systems, and we use excess heat a lot in the systems. So it's very important. You could say district heating is a very important part of these smart energy systems because it makes everything much more efficient from the overall energy systems side. If we then look at district heating, because in some countries do not have so much district heating, so we have been doing some projects called Heat Roadmap Europe, where we have studied what is the potential in Europe for district heating. And what you see to the left is a kind of result from Heat Roadmap Europe, where we have looked in this project is Heat Roadmap Europe 4, where we've looked into 14 countries and they cover around 80% of the heat demand in Europe. But in that, we have tried to look at how do we actually reach the climate targets, reducing CO2 emissions, but where we used these smart energy systems and district heating as a kind of method to reach it. And what you can see here is the baseline of 1990, and that's from the Paris Agreement. We use 1990 as a reference. Then you can see the emissions, how they are reduced. If we do a kind of where we just the one called BL 2015, that's if you take the current policies or the current policies at the time when we made the projects a few years ago, then you would reach a reduction down to these 3,000 megatons per year. And then if you go into decarbonizing without using district heating, then we have this scenario, what we call a conventionally decarbonized 2050 scenario, where we go even further down in CO2 emissions in 2050. So the baseline was a 2015 baseline. But if we start using district heating, but also district cooling, then we can actually reduce the emissions even further. So this just shows that by applying district heating in the same kind of system here, we can gain some efficiency benefits. And that's among one of the reasons why we can do this is that we can utilize some of the excess heat in industries and so on in district heating. So the systems become more efficient. Then what we have also done a lot of in Heat Roadmap Europe is to map district heating in the 14 countries you can see here. And what you can see is that we have the district heating shares in percent up here. The red one was the current in 2015, the shares we could find of district heating in the different countries. So what you can see is that some countries like Finland and Sweden here have very high shares of district heating already, while a lot of other countries do not have district heating. And in Heat Roadmap Europe, we then identified that there is a potential for increasing district heating in a lot of these countries. And that's based on a individual kind of energy system analysis of each country where we have mapped the potentials for district heating. So district heating is a very important technology. Then I'll just go on. But one important thing we then have when we talk about district heating, then district heating is actually an old technology. So we see it going back to the 1880s, where we saw some systems in New York and so on that are very old district heating systems. But district heating needs to also develop, so we don't only have, you could say, the current systems, but we have to make district heating more efficient. And that's where we talk about what we call the fourth generation district heating, where we reduce the temperatures. So right now, the district heating systems we have in Europe are what you would call second or third generation, where it's around 100-degree hot water in the district heating forward temperatures, where we aim at reducing these to make more efficient systems. And when we reduce the forward temperatures, then we also reduce losses in the systems, but we also open up for a lot of new energy sources. And this is where a project like ReUseHeat becomes very relevant, because in ReUseHeat we work with energy sources that are low temperature, and if we reduce the temperature level here, then we can actually use more of these sources more efficiently. Yeah, and that leads to the second topic in the presentation, which is the role of waste heat recovery in district heating. And if we look in the top, then you could say one of the strengths of district heating, and I also mentioned that before, is that in district heating you can utilize excess heat from other processes. So you don't just put up a boiler like you would in a house. You actually try to use sources from all kinds of sources. And you could say in traditional district heating, then we have used what we could call high temperature sources, which mainly comes from combined heat and power plants, for instance, where you use the heat that's produced when you generate electricity. It can also be from waste incineration plants. So when you burn waste, you can use the heat also for district heating, or it can be heavy industry where we have a lot of high temperature excess heat processes that produce heat that we can then use in district heating. So you could say that's what's been used traditionally and is also used still. And also in the fourth generation, these sources are also still important. And the reason for using these sources is then, besides that it's a kind of efficiency gain, that we are using fuels and so on anyway way up here, so we kind of gain efficiency by using the same for heat. But you could also say that these produce heat at a lower price than the alternatives. So typically when we see district heating that use a lot of excess heat, then they also have quite low heat prices. And then you could say now, due to some changes within both our buildings but also our heating systems, then these more low temperature sources has become relevant. And you could say this is linked to both buildings being renovated. So when we renovate buildings, then we need less heat to heat our buildings, which means that we can make the district heating more efficient. This change to fourth generation we just talked about. And then another thing is also when we start adding a lot of renewables in the systems, then in the electricity production, then heat pumps also become a good technology. The heat pumps can transform this electricity into heat. And typically you need heat pumps with these low temperature sources to actually reach the required temperature in the district heating system. And what are these low temperature sources then? And you could say that could be anything. And basically we would say that it's temperatures that are below these conventional district heating supply temperatures. So when we start to be below 80 degrees, then we start to talk more about low temperature sources. And I have just listed sources here, but there is an infinite amount, and we always we see projects coming up with new sources all the time for these low temperatures. But in ReUseHeat, we have focused on the 4 ones in the top here: data centers, metro stations, wastewater treatment, and service sector buildings. And then actually what I don't have on the list here is that we have also looked at food production and also food retail, where we have a lot of refrigeration, where we can use the heat from this process. But you could also say that using heat pumps with groundwater or seawater is also a kind of low temperature excess heat source. Yes, so that's how you define it. And as you can see, an important thing is that the low temperature sources have different temperatures, and that influences the efficiency of the heat pump. So if the temperature is close to what we need in the district heating systems, then the heat pumps become more efficient. And what we also did, an important thing when we talk about these low temperature sources, that is to distinguish between what we could call the available excess heat and the accessible excess heat. And I also have this schematic to the right showing the difference. And you could say the available excess heat That's what we call QL here, and that's the heat from the source, you could say. But as we just discussed, then typically you use a heat pump to boost this heat to the temperature you need. So you take some energy from the source, add some energy from the electricity, and then you gain what we call the accessible excess heat, or QH. And typically QH is higher than what we see in QL. So when you look at these sources, then it's important to know if we're talking about QL or QH. But QH is what is actually being used in the district heating system.
Well, the general reason why a mapping of excess heat sources is important is simply because excess heat sources are local assets that need to be understood from a local context. And for this reason, they are often overlooked in energy system modeling. And this is basically the most important reason, I would say, that mapping of excess heat sources is important. In the ReUseHeat project, we're looking at a certain kind of excess heat sources, namely low temperature sources such as metro stations and data centers. And this leads the way into the future, I would say. And this is also why the ReUseHeat project is particularly interesting.
And that kind of leads us into the third topic, which is the mapping of waste heat recovery potentials. Because that, of course, it's very important where are these actually situated. And to be used in district heating, then we actually need to have it within district heat, or close to the district heating areas. But as you saw in Heat Roadmap Europe, we have a lot of countries where we don't have a lot of district heating yet. So what we did in this project is that we used these urban morphological zones. You can see an example here of Berlin, where these are kind of high density areas where we have a heat demand above 120 terajoule per square kilometer. So high density areas, we said these could be kind of potential district heating areas in Europe. And then we looked at how many excess heat sources are there inside these areas in 2 kilometers and 5 kilometers and 10 kilometers from the area. So we simply just go out around the areas and look if there's an excess heat source up here, for instance. And then we can summarize all the excess heat sources. And we have done that for all of Europe. So you'll see that in a moment, where we can summarize all of the potentials and say what kind of potentials do we have for data centers, for instance, in Europe. So in the ReUseHeat project, we have mapped all of these sources, and to the right, you can see the different sources we have mapped. So from Heat Roadmap Europe, we have the conventional excess heat sources. Then we have data centers, the green ones, metro stations, the purple, food production and food retail, the orange and red ones, and then wastewater treatment. And you can see on this map of Europe, we have all the sources, and the map is grouping the sources. So if there's a large circle, it's typically a group of several sources. And if we zoom in into one of our demonstration site cities, Berlin, here, then you can see kind of the local potential. So you can see the more we zoom in, the more detailed it becomes, and some of the sources turn small because then we don't have several sources, but only one. And if we zoom into Berlin, we could say if we are interested in one of these sources, it could, for instance, be food production. Then we can see there's a food production facility here, the orange one. And you can also see where, if we zoom out again a bit, we can see the gray area. That's these urban morphological zones where we have assessed there's either is district heating or is it potential for district heating. So you can zoom in and you can find, for instance, a food production facility here, and you can click on it, and then you actually have a lot of data here, and you can find the potentials we have assessed for this specific food production facility. And you can do that for all the different sources of a city. And we have done it on kind of the whole EU scale. So Berlin is just one example, as you can see here. You can go to other countries and you can find potentials. If you wanted to go to, for instance, Madrid, you could also see the potentials here. And these are very localized potentials. Yes. And of course, the mapping of these potentials depend a lot on the data availability. So for some sources, we actually have more data. So I would say that this is a kind of conservative map. Yes. And you could say the basic thing we do when we map sources, then we have a kind of allocation sequence you can see here, where we have what you could call the theoretical maximum potential of a source, which is 100%. Then you could say there is typically some delimiting factors that limits the source. So for instance, the temporal allocation, you will also see that later in the presentation. When do we actually have the heat compared to when we need it, can limit the source. Then you could say the geographical allocation also limits the source. So if we have a lot of sources outside district heating areas, then that would reduce the potential a lot. And you can also see that on the next slide. And then you could say there is also kind of what you could call the practical economical potential. So even though there is a potential within district heating, it's not necessarily a good idea to use it in district heating. So then you need more local energy system analysis. And that's actually what we have been doing in the later parts of ReUseHeat. So you will see that in the last part of the presentation, what is the actual influence of this more space, the temporal approach, you could say. But if we then look at when we summarize the maps from before, then you could see here we have the available heat is QH, and then you could say, oh, actually that's the accessible heat. The available heat is QL, and the accessible heat is QH. So that's when we add the heat pump. That's also why you can see a COP here. So what you can see is out to the right, we have the total potential in Europe, and you can see that that here the accessible heat is larger than the available heat. And out here, it's without doing the temporal allocation. So this is simply just summarizing all the sources without looking at where do we have district heating, where the two next ones here is actually looking what is then within district heating. And you can see that there's a huge reduction in potential. And this is if we take within 2 kilometer distance to district heating, then we actually reduce it a lot here. And if we compare this total to what is the heat demand in Europe, then the heat demand in Europe is around 12 to 14 thousand petajoule. So this is around maybe 10% of that of the potential in Europe if we use all these sources we have. But as I said, this is kind of a conservative estimate. But it's a significant contributor, or could be. And you can also see here that we have different potentials for the different sources here. So you can see in this analysis we have a much higher potential for wastewater treatment plants and service sector buildings, but also data centers where metro stations, food production, and retail is a bit lower here. So that's both linked to what data do we actually have available, and also the size of these, where, for instance, when we take metro station and food production, it's typically very small systems. So in the overall, and also we don't have metros in all the cities in Europe. So that of course limits this resource a bit. Yes. If we then go into waste heat recovery on, I call it national and urban scale here, but that's actually the energy system analysis, where we look into, instead of just mapping the sources and comparing the totals, then we look into the temporal resolution, the when do we actually need the heat. And we did that both on a national scale for all the countries where we have demonstration sites in ReUseHeat, and then we did it on urban scale for the cities. where we have demonstration sites. And you could say both for the urban scale and the national, we have some general kind of conclusions. So I will not go through all the different scenarios and so on in these analysis. But you could say one important thing is this temporal availability, where you can see this is just distribution files, so don't pay too much account to the numbers here, but it's more, we have all the hours in the year, and then you can see for these 4 sources that we also map: data centers, wastewater, metro, and cooling from service sector. Then we can see some sources are available all year round. For instance, data centers and wastewater treatment goes a bit down in some parts of the year and up in others. But they are basically available all year, where the 2 other sources, metro and service sector cooling, is very linked to when do we actually have high temperatures, and that's mostly in the summertime. So that's very important, that a large part of this, even though when we look at cooling, then it's from the service sector, it's very high, but we also have it in the summer where we don't necessarily need it. So that's one aspect that's very important when you talk about these sources. Then another thing is the temperatures of the sources, and that's linked to the efficiency of using the sources. So the higher the temperatures are here, the more efficient the heat pump becomes. And you could also say, if you compare this to the district heating, then if we have 4th generation district heating where the temperature is maybe 60 degrees, then you could say a data center only needs to boost the temperature to 60 degrees, so it's more efficient than, for instance, using wastewater as a source. So that's another important thing, the temperature of the source. And then the last thing, which we could also see from this is from the national energy systems, is that there is a competition with other heat sources, and that's very relevant when you look into these sources. Is that if we have the orange one down here is what we call conventional excess heat, so that's the ones we talked about before that are higher temperature. And because they are higher temperature, then they don't necessarily need a heat pump. And that means that these are typically cheaper than using these low temperature sources. So if you have a lot of these conventional sources, then they will kind of remove some of the potential for using the low temperature sources. But in the system, you can see here, the low temperature sources are the ones called heat pump heat sources, the kind of blue one here, or what you would call it, green maybe. But here you can see the heat demand over time, and you can see there's space for this excess heat. And this considers prices and so on in the electricity system. So that's probably why when we see the CHP, the orange one, taking some of the potential, that's probably because the electricity price is high, so it's more expensive to use the heat pump, but good to use the CHP. But that of course fluctuates over the year. But if we take this example, then this is from Spain, where you can see the weeks over the year. And then you can actually see what we see over here, that we have a lot of the excess heat is actually available in the summer. But if we compare to the district heating demand in Spain, then it's low in the summer. So that actually means that this kind of limits how much of the excess heat, especially from the service sector, we can use. But it also shows that if you have all of these sources, then they can potentially start to compete. So the ones operating the district heating system have to choose, would we rather use data centers than service sector cooling and so on when they operate the system. And then I just took kind of the conclusions for each of these reports, and you can find them on the website of ReUseHeat. So this are just the general conclusions, because we have so many results that it's very hard to show in a presentation like this. But we have a lot of learnings from the national systems, and these are based on looking into Germany, France, and Spain. where we have some learnings, and we could say the main kind of conclusion from this is that using these urban excess heat sources or low temperature excess heat sources can both reduce cost and primary energy supply, and I could also add emissions to this. So the systems are benefiting from this system, and you could also say that that's kind of obvious because you would replace some other more expensive unit when you start using these sources. But nevertheless, we have analyzed it. We can also see the potential is bigger than what we can actually utilize in the countries, and that's linked to what we see before, either where we have district heating, so the geographical limitations, or these things with the hourly resolution, where when we have the heat, then it's not necessarily available in the hour where we need it. And in the analysis, we have also added some storages, because you could say if you have heat storages, then you can actually move some heat. But you would need very large seasonal storage to actually move all this summer heat we saw from the Spanish example, for instance, if you want to move that to the winter. Then another learning is that all the types of heat sources can be feasible, but it depends a lot on the system they are used in. So when we looked into, for instance, France here, then we could see that there were actually a lot of these more conventional excess heat because of the scenarios we used were from Heat Roadmap Europe. And in that, there was a lot of kind of fuel production. So the ones we saw in the smart energy system presentation, we had some fuel production where you produce electrofuels, and a lot of that is in the Heat Roadmap Europe scenarios placed in France. So you could say that actually started directly competing with these low temperature sources, because then we had a high temperature source, where we would not see that, for instance, in Germany or Spain. So the heat sources were more feasible in those systems. Then you could also say, and another important thing is that the availability in the winter or in the cold months is actually defining how much is feasible to utilize. So when you design how large should the capacity be of utilizing these low energy sources, then you would kind of say how much can we produce in the winter when we actually need it, and set it to that, because otherwise you would overinvest in capacity to produce heat where you don't actually need it. And that, of course, again, depends a bit on the systems and if you have storage and so on. But as a general conclusion, it's very important how much is actually available in the cold months. We also couldn't find any significant difference between the feasibility of the sources, and that's because all the sources need a heat pump. So you could say it's mainly down to the temperatures and how efficient is the heat pump and so on, but typically that's more efficient than using the traditional sources, so then it becomes feasible to use these sources. And then we have a last one, is that the baseload heat supply actually is also limiting the feasibility of these low energy sources, or as it says here, it says the heat pump, but if you have a lot of baseload supply, and that could also be if you're operating, for instance, a CHP plant as a baseload unit that doesn't operate flexibly, then you would also limit how much you can actually integrate here. So you have to look at all the other heat production units to actually make these feasible sometimes. But it also depends a lot on what quantities are we talking about, because in the beginning, you would start with lower amounts of these low temperature sources, so then there's almost always room for it. Where in this analysis, we actually try to use everything. So that's where we start to actually see these typically. If we then look into the learnings from the local energy system analysis, then we have looked into the demo site cities, Berlin, Brunswick, Nice, and Madrid. And you can find it in this report, the more detailed analysis. And the conclusions are kind of similar. So we can see these large heat pumps based on low temperature sources are a more efficient, cost efficient option for district heating. So it kind of underlines what we could see from the national analysis. But here we are actually down to looking at the sources and energy systems of these cities. We can also see that if you add them balanced share, so we don't take all the excess heat, but some of it, then we can also lower the general cost of the system. We can also see that this thing we could see in the national, that when we have a lot of these high temperature excess heat sources, that actually limits how much can we actually cost efficiently use of the low temperature sources. So that's a very important learning here. And then we can see that you could also say that these sources they have the potential to actually develop district heating. So in a lot of areas where you don't have district heating, if you have low temperature heat sources but are actually also high temperature sources, then that could actually help making district heating a good idea in these areas, and we could see that from these local systems also. Then another thing that we did not have in the other system, but if we have a local system where you only have heat only production, so boiler systems you replace, then it's more efficient than if you have, for instance, CHP production you're replacing. And you could also say this conclusion is also linked to if you use a lot of fossil fuels, then it's typically more efficient to replace it. So that you could say the feasibility of the low temperature sources depends on what do you actually replace it with. And then you could say again, the availability of these excess heat sources is larger than what we could see here is cost efficient to use. So it's more a matter of how much do we actually want to use. And then I've just summarized kind of the key takeaways from all of these parts. I have 4 points here. So you could say district heating, or the 4th generation district heating, kind of future systems, is an important technology when we want to decarbonize the whole European energy system. We can see huge benefits of this technology. And within these systems, then we can see a benefit of utilizing these urban low energy heat sources, where we can both reduce the primary energy sources used for energy production, we can reduce the emissions and also the costs of the systems. Then we can also from the mapping see that we have many of these low temperature excess sources available, and they are available within the urban areas all over Europe. And we also know that the mapping is kind of a conservative estimate, so potentially we have much more than what we have mapped. And then you could say the feasibility of the excess heat sources depend a lot on the energy systems they're used in. So you cannot say that it's always a good idea to use low temperature sources, but if they are replacing kind of fossil fuel boilers, for instance, then it's almost always a good idea to use it. That's all I have for the presentation, but I also have a slide on further reading. So on the ReUseHeat website, you can find the reports that all of this is based on. If you want to know, for instance, how did we map data centers, then you can find that in this report 1.4. We also have some published scientific articles. There's also one on the way about metro stations that you can use as further readings. Yes, and now I'm done.